the input voltage of 12 volts was actually going through the regulator and onto the 5-volt rail, which has broken a few things, and including the CPU on this board. So I'm gonna take the other board, which I've also powered up, which had the same issue and which also had a little puff of smoke coming off the board, and I'm gonna see if that board still has a working CPU. And if that board doesn't have a working CPU, then I'm gonna take a new board, which hasn't been powered before, and I'm gonna make sure that the regulator works before powering on the board, and then we'll see if we can flash that board, and we'll see if everything works on that board, besides the possibility of having a shorted regulator. So let's have a look here. On this board, I'm gonna put the CAN transceiver back on, just so that I don't lose it, in case it's still okay. So my theory first was that it was the CAN transceiver that was broken, but it seems to be more than that. So I'm just going to solder back the CAN transceiver, and I'm going to disconnect this board from the power. It's actually not powered right now. It's only connected to the power supply. Let's see. And I'll then connect the other board and see if I can get this board working. And on this board, I'll just have to replace the CPU. Start from there, and then if there's anything else that needs replacement, then I'll have to order the parts and get this board fixed. So on this board, it is exactly the same issue, that there is 5 volts coming out on the 3.3 volt rail, and I think, let's have a look here. I think it's one of these chips, the encoder chips, that's also burned down on this board. So I'm going to desolder those chips, and then I'm going to also solder the LDO regulator, which I think is actually okay. I thought that was the regulator that was broken, but it's actually one of these chips that's connecting the 5 volt rail to 3.3 volt rail, because these chips accept both 3.3 volts and 5 volts. So this will have to be, let's see, where are my fingers? There. Okay. So I'll solder on the regulator. And I'll desolder the, let's see. And I'll desolder the chips that I think are shorting the 5 volt rail to 3.3 volts. Okay, and then now it's time to desolder these chips. I'm going to put some flux on them so that they are all drained in flux. And I'm going to heat them up with a little bit higher temperature, because this is unleaded solder, so it's difficult to melt compared to leaded one. These boards are factory soldered. I'm not going to pinch the chip too much until it's completely, until the solder is completely melted. Because I don't want to break the pads on this chip again. Could be that the CAN transceiver is broken as well. I don't know. It could have gotten above 7 volts as well. But I would imagine that the CAN transceiver is actually more robust than these chips. And I hope that the CPU didn't see above 4 volts, because that would have completely destroyed the CPU. So I have separate power rails for the CPU and the rest of the chips. So even if the 3.3 volts that's feeding the rest of the chips has seen above 3.3 volts, there's still a slight chance that the CPU maybe still is okay. But of course, those other chips are connected directly to the CPU, so if there is any signal going from one of these chips to the CPU, then it would have been above 3.3 volts. So in that case, CPU is probably broken as well, which is rather unfortunate. But nothing that is not fixable, but still quite annoying. Okay, got this one desoldered, and fix the pads so they don't have any solder bridges, and then I will once again try the then I'll see if I still get the wrong voltage on the 3.3 volt rail, and if not, I'll try to flash the chip. So let's connect the power. Always remember to connect the power. And I think it's fine, because there's nothing else nearby those chips that would get hot. Besides maybe this, but this is not hot. So let's see. Yeah, of course. So here I need to solder the resistor, which I've desoldered before. And I need to have something, I need to find the resistor, like a 0 ohm resistor to replace this resistor with, because when I desoldered that resistor, I was heating it up for way too long, so it actually got a little bit melted. So I'm going to replace it with a new resistor. Which doesn't need to be a current sense resistor in this case. I'm going to see if I have a 603 resistor, which is 0 ohm. Oh, actually I have an 805 resistor. Maybe that will fit. It's their other big current sense resistor compared to the other resistors. Like, it's not a 402 resistor. It's probably something closer to 805. So I'm going to grab an 805 0 ohm resistor, and I'll just snag it on there, and we'll see if we can get the chip to work. Yeah, it's actually 805. 805 fits perfectly. get some of the leaded solder on. Okay, it's not perfect, so I need to make it a little bit better. Getting now 5 volts in the output. Yep, it's 5. No. Don't go above 5 volts. That's not good. That's definitely not good. But this one's 3.3 volts, which is good. So the 5 volt regulator is still not entirely working, I guess. So we'll get something that is actually functioning here. Interesting. And I think it's gonna go beyond that, yeah. So this needs to be fixed. I'm going to make sure that the inductor is also connected properly. It seems to have a little bit too little solar paste underneath it. And then just wiggle the 5 volt regulator a little bit to make sure that it's soldered on properly. Okay. Maybe this is gonna work better. We'll see. So in case you haven't been watching this video from the beginning, this is the other board that got zapped by too high voltage on the 5 volt regulator output, which has been caused, I think, by a short underneath the regulator, because it's quite a small chip and it has the solder mask wasn't actually getting between the pins, so there's a big chance that there could be some solder bridge underneath the chip, and if that has been the case, then that would explain why I was getting the input voltage on the output of that regulator, which seems to have killed a few components around the board, but I will just try to check if the CPU is okay on this board. It has most definitely killed encoder interface chips, at least one of them, which was then shorted, which actually then shorted the 5-volt rail to the 3.3-volt rail, which in turn could have destroyed the CPU, but we'll see. And the next step after this board is to take one of the assembled boards that has not been powered yet, and just make sure that the regulator is soldered on properly and that it works before going above 5 volts, just to make sure that nothing is gonna get more voltage than it is rated for. So let's have a look here. I'm gonna check now if I get 5-volt regulated voltage here on the output, or if it's still gonna go above 5 volts. Now it seems to be regulated. Okay, so let's have a look here. So this is at 3.3 volts and the CPU is at 2.4 volts. It looks like the CPU may be actually shorted. Could the CPU be shorted? Am I getting just 2.4 volts? Yeah, I think it's most definitely the CPU is shorted. But let's have a look if we can actually communicate with the CPU regardless. I will actually check if I have a short to ground somehow. What is the resistance here? 10K, which kind of makes sense because I have 10K resistors. Yeah. Maybe the chip is not soldered on properly. I'm just gonna double check that first. Make sure that the solder joints are okay. Because I had to remove this regulator because I thought that the regulator was broken. But then I realized that it's not the regulator, it's actually the encoder chips that were pumping more voltage into 3.3-volt rail. But that could have destroyed the regulator as well. One of these two pins then. Let's see. 4 is unconnected. Okay. Maybe it wasn't. Maybe actually I was getting the voltage on the 3.3 volt rail here that was actually coming from the from something that's connected to the CPU. So maybe it was actually powering the CPU through some pin. So let's have a look now. If I increase this, do I get 3.3 volts? Do I get 3.3 volts here? No. For some reason I'm getting 2.42 volts. I still feel like I want to make sure that this LDO is actually soldered on properly. But I'll remove the LDO and I'll see if I get the same voltage. That could be an interesting thing to try. Actually, I'm pretty sure that the LDO wasn't soldered properly. It needs to be heated a bit more because the solder is kind of a mix between unleaded and leaded. Unleaded from the factory and leaded from my solder chip, the tip of my solder iron. Let's see. Come on. Make sure that this chip is properly soldered, because it isn't properly soldered right now. As you can see, it's just actually I'm going to just remove the chip and retin the pins. Actually retain the pins before. This seems to be soldered a bit better than before. But one of the pins is still kind of not making contact. Or the way it looks to me. It looks like it's not making any contact. Alright. Is this going to give us 2.3 volts or not? Yep. And it's actually running! Look at that. So this one, I flashed this chip before, and it's actually running. So this one is working, and it's not getting burned by the 5 volts, and the CPU is obviously working on this one. But the encoder chips, I think, have been destroyed, which is a bit unfortunate. But I'll have to solder one of them at a time and see if at least one of them works. But I'll do that a bit later. What I'll do right now is just check if I get this shell here. Let's see. I don't get that one because I need to connect the serial port. And I'm going to just double check that I have the voltage here. Yeah. So now all of the peripherals are powered on this chip, not just the CPU as it was before when I was flashing this. I'm going to just reboot this board and see what we can see here. So I think I'm getting errors there because I'm not finding the encoders. Yes. So it's just the encoders. Everything else seems to be working. Of course, I'll have to double check with the scope that I get output on the PWM output on the motor connectors. Let's have a look at that. Do we get any PWM output? And then the next step would be just to test everything. Everything else is working. Let's see. Is this which channel is this? Is channel 2. I'm going to be getting anything here. Okay. This is the normal mode. Is there not? Interesting. Oh, we got something there, but not on this side. So motor number 1 is working, motor number 2 is for some reason not working here. Could it be that the... No, volt is not... yeah, interesting. Power off the chip, power down again. Let's see. Yeah, now it's working. So it must have been that something got into an error state because I was increasing the voltage very slowly. So now all of them are working. So all the motor outputs are working, and I have really no reason to believe that something else is broken, unless of course there is some similar problem with some other chip where the solder mask is not between the pins of the chip. So essentially maybe something else could be shorted. But I think that this 5 volt regulator is the only chip that has that distance between pads. It's a very small chip. Possibly also the CAN-FD chip, but it's not mounted on this board. It's quite possible that everything else is working, but I'm going to check that later. Right now I'm going to go to the next board, which hasn't been powered before, and I'm going to make sure that that all of the other boards work. So I will stop this video, and I will start a new video in a bit, where I'll bring up all of the other factory manufactured boards.